Good morning, everyone. Welcome to my presentation. Today, I'm going to show you how you can secure your code like NASA. Like Matthias said, yesterday we have a talk on CodeQL from Jonathan at 1 o'clock to 2 o'clock, where he showed the perspective of the security researcher. Then we had a lightning talk from 6:15 to 6:30 from Mikhail, showing how he uses CodeQL in his PhD. Today, I'm going to show you what we believe at GitHub the future is for software security. I'm going to show you a new methodology we developed called security as code. And I'm going to demo for 20 minutes CodeQL on screen by coding. So my goal after this presentation is for everybody to leave this room with the basics in mind and provide you with resources to get your journey started. And like Jonathan said yesterday, whatever I'm showing is free for open source, which is amazing. A bit about me. I'm part of the GitHub Security Lab at GitHub, which is a security research team. Before that, I started doing cybersecurity as a teenager, so it's been like 10 years now I'm into cybersecurity. My favorite highlight from the research I've produced all these years is the fact that when I was at university at Imperial College London, I've shown a zero-day vulnerability for a top 10 blockchain cryptocurrency at the time. It's my favorite because many things are innovative, and that's amazing, but at the same time, they should be secure. I'm also sharing tips online on how to secure your code. I'm playing on the developer side. You can see me at the official GitHub account or sometimes in YouTube, where I have a series. The reason I created this series is because I've seen so many videos on that's a bug, that's how you can exploit it, etc., but nobody really produced a video sharing that's a bug, that's why it occurs, that's a pattern you can avoid, that's how we can eradicate it forever. Now, my team, we have the mission to secure the open source software that we all depend on. So we are researching for vulnerabilities in the open source software. And from the month of March 2020, which is 2.5 years ago, so it's 900 days, we found this number of zero-day vulnerabilities, 337, which is like one zero-day vulnerability every 3 days in major open source software that everybody uses in their everyday life, even if they don't know about it. Like, for example, the previous presentation on Tesla. If you buy any car and you open the car manual, you'll see in the very first paragraph speaking about software that you accept the use of open source software. Other initiatives that my team does to secure the open source software include the fact that we open our time for free to open source maintainers maintaining big projects that come to us and they talk us about their struggles in cybersecurity. All those things that they are unclear about. And I had so much learning over the past year about this that I can't predict what's coming, why it's coming, and why we may or may not have another Log4j in the future. You see this when you speak with the maintainers and you understand their struggles in cybersecurity. Now, I spoke in my title about NASA, how NASA secures their code and how you can do the same thing very easy after this presentation. This snippet is not the actual snippet, but it's very, very similar one to some code that NASA had 10 years ago when they sent a rover to Mars called Curiosity. This little rover will fly by a rocket, and then this rocket will fire the rover. The rover will come down slowly to Mars, and the parachute will open to allow this to happen so that the rover will explore. However, there was somebody in the team there. Some people are like 20 minutes after they leave the house and they are in the car, they start asking, did we turn off the heater? Did we did this? Did we lock the windows? Same thing. A NASA engineer asked, do you want to check for one last time the code that is responsible to open the parachute of the rover? Did anybody spot the problem in the code? Does anybody want to share? Yep. Absolutely. Thanks so much. So that's correct. The signature of the function is expecting an array of 12 elements. In the loop, you have an iteration of 12 elements. But then in line 7, you have one of 3 elements being initiated. This means that from the element in index 4 onwards up to index 12, you can have, not you can, you will have random behavior which can cause the rover to crash. The smart things that NASA engineers did, and that's what I want you to remember, is that they didn't just fix that vulnerable instance of the code. They realized that if we have a mistake there, it's highly likely that our coding style is like that. So the way we produce the code in general can be affected by this kind of problems. And they wrote a query in the language CodeQL that Matthias said, and I'm going to show you, to pick up bugs like that in the overall code base. And they found 30 other variants of that vulnerability in their code. They fixed those variants, and the Curiosity rover was able to land safely in the surface of Mars. 1 year ago, actually 14 months ago, NASA sent another rover to Mars. This time was called Ingenuity, to do similar things. This time, 10 years later, they had so much more learnings, right? They could use other products. They could bring their security level into a whole new level and avoid mistakes like that of the past. I promised to talk about the future of software security. We believe that the future is developer first. And I'm going to show a demo on what I mean by developer first. And then I believe that it's community driven. So developer first, in theory, is when everything happens from inside the same place, so that a developer can secure their code from where they code without actually going to another place, log in here, log in there, found the problem there, go fix it, push, blah, blah, blah. This is a losing game in the long term. Our research says that, and we've seen this happening a lot of times. In 2-3 years from now, if you are doing something like this, the developers, they are going to naturally abandon these solutions. And then I spoke about community-driven. The way we implemented CodeQL is that when NASA fixes a bug by writing a query, when NASA detects a bug by writing a query, we can have that query as well. And we put it in a database where we have our cumulative knowledge of problems we found so far that my team is finding with the 337 CVs, enterprises like NASA and so many other big organizations in the world, and also hunters, people who are paid bounties, like Jonathan yesterday, to contribute queries to us. And all those queries, we have them in a nice database that you can build on top and benefit from all that collective knowledge from the past 10 years. We call this, come on. Yeah. We call this security as code. It's a methodology that we have been inspired from DevOps. So historically, people would open tickets in infra teams. They became slow, basically. From the time that developers had the chance to write infrastructure as code and DevOps, etc., they start to become faster, and at the same time, everyone in the company was looking at the same thing. Therefore, they would speak the same language. Developers could read that, could understand, and they could extend. In the same way, we've seen this happening in quality assurance. I don't think that a practice of the past when people were like opening tickets and had to speak with 10 different teams or 3 different teams to do things is going to resonate with people nowadays in software engineering. And we define security as code as the methodology of codifying security decisions that are then shared with other teams. In an ideal world, we want every security expert within an organization to codify their security knowledge in such a way that can be then socialized with the rest of the organization. This can be policy as code. This can be security as code. This way, security is in the background, is not a stopper, is more like a seamless integrator with anything else, and you only pay attention to the security alerts if and when those are created. But again, remember, you all speak the same language. Developers would read the code that security experts have codified their security knowledge on. Therefore, you will all work on the same thing. Now, CodeQL. CodeQL allows you to query code as if it was data by describing what you want to find, not how you find it. We are using CodeQL as the mean of implementing our vision, methodology, idea of security as code. CodeQL was created by a company, a little company in Oxford, England called SaC 13 years ago, 2009. Then GitHub was bought by Microsoft in 2018, and GitHub bought SaC in 2019. So you have this transitive acquisition, basically. CodeQL, it's like Mikhail said yesterday in his lightning talk, it's a declarative language. You say what you want to find. You don't explain how to find it. And it's also a logical language. It's using operators like and or. If I give you an example in English, it's like, from all these people in the room, give me that person who is standing and wearing a black jacket. So you never say, go to this place in Stockholm, and get inside, get this person. So you use the type of human, which someone implemented once, and from there, you narrow down like SQL. At the same time, it's an object-oriented language, and what I described is object-oriented because you start from all the humans and you go down based on characteristics. Now, we spoke about querying code. Querying code is not just for security research. It can be just because you want to familiarize yourself with a code base. Like, for example, when I spoke about the research I've done for Imperial College, finding this top 10 cryptocurrency, well, this top 10 cryptocurrency was a Bitcoin fork. Do you think that I started reading like, I don't know, 65K lines of code? No. I tried to be smarter by explaining, by querying code, and navigating to those points that actually matter, the pain points in the code base. Behind the scenes, your code base is transformed into an abstract syntax tree, a relational database that is going to be able to be searched. This thing, we call it a database. So you condense your code base automatically with the tool into an abstract syntax tree that we call a database, and it becomes searchable by queries. You can view this abstract syntax tree by using the AST viewer. I'm going to show this in my demo. And then to better manage expectations, and that's a question I hear a lot, it's a SAST tool. It's not a Dust tool. It's not going to run the code. It's going to perform static analysis. However, we've seen over the years that some alerts that we are getting, and we thought that, is this a false positive? Is this an alert? They have been actual alerts if the specific right malicious input was given to them. And many people also ask about false positives. Of course, we are doing our best to maintain that cumulative knowledge database we have we have as polished as possible to the level that my team jokes with me that I have more chances to do like crazy things in life than a bad query arriving inside this code base. And at the end of the day, the language is declarative and logical. So it means that we code in such a way that is generic. Therefore, something that can be considered a false positive for me might not be for someone else. False positives are subjective. So we bring every single query into a very polished form where you can start from like satisfying 95% of people, and then that 5% of people can tweak this query a bit and arrive into where they want to go. The languages that are supported by CodeQL right now to perform SaC is Python, JavaScript, C++, Java, Rust, and Go, with the roadmap having Ruby and Kotlin coming up very soon. And I have some other languages in mind, but I'm not sure if I can share because I'm not sure if it's public yet. OK, I'll keep it here to be on the safe side. The way you write code in CodeQL changes a bit for every language. Today, I'm going to use Java. But even if you don't know Java, I'm going to be so like basic at what I'm doing that everybody who is living and want to experiment with CodeQL, even if you want to do Python, 99% of things I'm going to show is still applicable. So we are in a security conference. So I want to show a demo that applies to the active user that I believe can be a security researcher, someone who wants to find vulnerabilities in the code. At the same time, though, I want to show how a passive user can use this tool, because I promised to show you how to secure our code like NASA. Therefore, I'm going to show how you can turn the tool on and how it's going to work when you push code, so that you can benefit straight away by a few clicks. Starting from the passive user, I want to first show you how to enable CodeQL for an open source public project. To do this, I'm navigating to my GitHub profile, and I have a public repo here that doesn't have code scanning enabled. So to enable code scanning, I can navigate to the security tab of the repo. You should be the owner of the repo, by the way, and click Set up Code Scanning. We try to integrate with as many SaaS tools as possible. The one I want to show you today is CodeQL. So I click on the configure here. And here you have a YAML file that doesn't really need any changing, apart from choosing the language your project is on. And some people also like to use some flags, like security extended, which has a bit more noise, and security and quality to pick up problems that the majority of the users might not be interested at. And by committing this, you have a GitHub action created on your behalf that every time you push code is going to be triggered. And to show you how it's looking when it's actually enabled, say that this is a public repo I have. I just pushed code in there, and we have 9 alerts. So if I come here, view alerts, I got these problems flagged by CodeQL. If I click on one of those, I can see that the first one is use of a broken or weak cryptographic hashing algorithm on sensitive data. The problem is explained alongside the CWEs. You can click and learn more. And we are currently implementing some features that are going to be public soon, where you can have a discussion with your team below each bug, fix it, and push the code. As you can see here, the problems being picked vary. It can be pretty much every vulnerability, which shows that you can model vulnerabilities by describing how they look. Today, I'm going to demo a vulnerability called SQL injection. I'm sure the vast majority here is familiar with this. And I'm going to use your familiarity to write CodeQL from scratch to pick up SQL injection problems in a code base. So moving now to the active user, to one that is going to actually write CodeQL for their code base. This is a meme from XKCD. And for those that are not familiar, that meme behind the scenes would look something like this. So insert into students, a name of a student, the developer, where you have the name Clio, falsely assumed that all users have good intentions, therefore they are just going to pass a student name. However, in reality, someone with malicious intentions can pass a student name alongside commands. This can be dropping a table, it can be extracting sensitive information, such as, in this case, it doesn't apply because you have students. OK, it can be college students, like credit card information, et cetera, et cetera. Or they can make themselves an admin in the code base to do whatever they like. To model this vulnerability, I have to introduce some definitions, starting from the source. The source is the source of the vulnerability. It's the place in the program where malicious user input can enter into the code base, like this one in our example. Then you have the sink of the vulnerability, which is where the malicious input is actually being executed. Because if you have malicious input that is not being executed, you have a vulnerability that is not going to be realized. And in our model, the vulnerability only exists if there is data flow between a source and a sink. Therefore, this means if there is a flow from a malicious input getting in the database to the place that is getting executed, yes, you have an SQL injection. And just to revise, the sink in the example we've seen is where the SQL query is being executed. So that's the model I'm going to demo in writing CodeQL. I'm going to use, before that, so first of all, I'm using VS Code, the text editor. I have the extension of CodeQL being installed. In here, I have transformed the innocent code base that doesn't know it's malicious, we'll see, into a database, which is the OWASP mobile shepherd. Think about a mobile app that when you click on it in your Android mobile phone is asking you for a username and a password to log in. So I transformed the code on the right, which is the mobile shepherd code, into an abstract syntax tree relational database that I can view using this button here in order to be able to search. And on the left, we have the source of the vulnerability that I'm going to model, is the place in the program where malicious input gets in. Then we have the sink, which is the place in the program where the malicious input is get executed. And finally, we have data flow, where we are going to model if the source ever gets to a sink to see if we have an SQL injection happening. Like Jonathan and Mikhail said yesterday, the real power of the language happens when we do taint tracking. So bear with me until the data flow query to judge what is this guy doing or what he thinks he's doing. So first of all, the source of the vulnerability is in line 98 and 99, where a username is being accessed and gets into the database by the method called getText. If we model this with CodeQL, first of all, I want to import Java, which is the standard library from Java. So I can benefit from all those methods I'm getting for free with the library. Then it looks like SQL, but it's way more expressive because it's object-oriented. And I have a from, where, and select clause. So like before, I said, from all these people in the room, give me that one standing in the black jacket. So we want to say something along the lines of, from all the methods in the program that are being invoked, give me that method which has specific characteristics so that malicious user input gets into the database, into the code base. Let's start step by step by saying from all the methods in the program, therefore from all the methods being invoked or accessed in the program, give me all those methods. Here we have method access, which is a type, and then we have a variable, like a call. It can be C. It doesn't matter. You can call it whatever you like. And if I run this code, I expect CodeQL to give me back all the methods in the program, which isn't helpful because not all methods invoked in the program are malicious. Some of them are. Those who are getting, or some of those who are getting malicious code into the database. So to filter those methods, and just to give you a visual understanding of what I'm doing, I started from all the methods in the program to arrive into the getText method, where user input gets into the code base. We never know if this input is malicious or not. We are going to expect the data flow to show us that. We expect CodeQL to pick up confirmed findings. So if I want to narrow down this to the specific method, by clicking the dot here, I'm getting suggestions. I want to use the get method, which is going to be able to access the methods in the program. And then I want to be more descriptive and use the has qualified name. I'm getting like explanations of what everything is. And then I want to show here that I'm on the Android.widget. The type of all methods that are accepting user input is edit text. And I'm interested in the specific method called getText. If we run this, we expect to come up with the getText invocations in the code base. These are 3 of them. If I click, I can go to those. But you never know if all 3 are malicious. I know that so far it looks like a command find or grep exercise, but in the final thing, when we have the data flow, you are going to see the real power of the language. Now, the sink of the vulnerability is where this input is going to get executed, if it ever gets executed. And it's the first argument in the raw query method. I've seen people just saying, oh, whenever raw query method is being executed, you have the sink. No, that's a false positive. That's why you get false positives. You should be more descriptive. You should say that the sink of the vulnerability is where the first argument of the raw query is, because based on documentation, the raw query method is executing an SQL query as the first argument, and then in the second argument, you keep passing other arguments. So if we see this in the code, actually it's better to see it in action. So let's make CodeQL to give us that code instance. So far, I wrote the same thing that I had before in my source, so we save some time, which says, from all the methods invoked in the program, give me the one that is raw query. To be more descriptive now, I'm using the logical AND operator, and I want to access a specific argument, which is of type expression. I have a variable here called arg, and I want to be more descriptive by saying, and this argument is where the first index of the raw query method, which is index 0, because we are software engineers here, is. Therefore, if I run this code here, I expect CodeQL to give me only those invocations of raw query method that have the first argument being set. So if I click on this, that's an instance of the raw query method with the first argument being set. And here's another one. Now, I promised you that data flow is where the magic happens. Here we have a template. CodeQL is full of templates. And that's what made me faster when I started my journey with the language. I didn't write this code. I don't know who wrote this code. It can be someone from NASA, it can be someone from my team or another enterprise. The thing that I care about is that I can be more productive because somebody gave me this code that is just having two to-dos in the predicate is source and in the predicate is sync for me to build on top and be faster. Therefore, I guarantee that it's very rare for people to start building queries from scratch. Normally, you build on top of things. Like, for example, when Log4j was out in mid-December, and we created a query about it, then people started to build on top of that query by changing a few things to find the next, let's say, variant of Log4j later. In this file, you have a bit more things. Like, for example, at the top, you have metadata. Just ignore them for now. Then you have some other libraries that are going to help us to visualize the data flow functionality if and when we have SQL findings that are confirmed. And then, because it's object-oriented, I'm extending the taint tracking configuration to benefit from all those methods that they are already defined. A predicate is essentially a function. So you have reusable portions of logic encapsulated in a method call. Now, before I copy and paste the code we wrote here and the code we wrote here to the data flow function, I want to show you how descriptive you can be with CodeQL. I want to say something along the lines of, there exists a method such that when this method is being invoked, it has some specific characteristics. And for a source, we know that the characteristics that this method has is the fact that it has the getText method. And someone might ask, oh, what's a node, by the way? Remember, we are having an abstract syntax tree. Therefore, I want you to think about data flow as being flying from a place in the program, a node of the program, navigating to another place of that abstract syntax tree. And that's why we represent everything by the node type in this specific example. So if I copy and paste this code here, that's a description of a source. I want to say that this node is going to be what I described above. Therefore, I want you to find me if there's flow between this node and that node. And I'm doing the same thing here. There exists a method. When this method is accessed, it has some specific characteristics. I can get those characteristics from here. And I want to model this as another node in the program. So it's a destination node. This is how we modeled an SQL injection vulnerability. There's a source, there's a sink, and if there's flow, we have a confirmed finding. I'm running this code now. And we have two confirmed SQL injection findings that we can run through together to find out if they are real and understand the power of CodeQL. So the first instance, I clicked on the button here, then I'm clicking here, and I have the pathway. This is very useful when you have the pathway, because you understand where it flows in the program, and allows you to understand the impact of the vulnerability when it flows in the program, and also allows you to fix all those places in the program that it flows from and to. First, if we click here, I think it's going to be easier if I move this in here. Perfect. Yeah. So clicking on here, you see that the malicious user input gets in the code base from the username. It then flows down to the login method, where there's a check performed. There's a check performed if the username and password passed in the Android app are evaluated into true. Then next stop is the login method, and finally it goes down to the query, the first argument of the raw query method where it's being executed. I want you to see this now. Of course, there's another pathway according to this. Who wants to guess what's the other pathway for the username method? What it makes sense to be when we use the login method? Since here we had an evaluation to true, the other thing that makes sense to be for the username is an evaluation to false. So I want you to compare lines 102 with line 116. I know when you are sitting back here, it sounds intuitive, but I've seen real security teams missing the second way or flow that this can happen. So if I continue the navigation, it flows to the login method, and finally it gets executed. And then we have the other confirmed SQL injection finding that it travels in the same pathway, but this time is the password method. And for the hackers in the room, yes, you don't need an account in the database to exploit this vulnerability, because, like we see here, it can just be evaluated to false. And that's the real power of CodeQL, giving you this taint tracking way of following your code, your malicious code if you are a security researcher, in the code base. So after this demo, I want to speak about also the extensibility and the flexibility of the tool. I'm sorry. If I show you in the text editor I was using, I open my files here. So let's forget this for now. On the left, you can see that this is my demo file, OK? But this is the whole CodeQL library. So if I go down here, you see a C++ folder, a C# folder, Java, JavaScript folder. Inside these folders, you have queries of vulnerabilities that I can use to build on top of and start hunting. So I can extend and flexibly use the work of other people in the past. And finally, that's the most important slide, I think. We work as community. If we find something, we contribute into the code base. If the community finds something, it contributes into the database of queries we find so far. Same for hunters. So the future, in our opinion, is developer first. Everything should happen inside a pull request, like we've seen with the alerts, and also community-driven, because we are in Stockholm now, but if some company in San Francisco finds a bug, why do you need to suffer as well? Why we don't use the knowledge of somebody else to save time, effort, stress, and let's focus on growing the companies. To start your CodeQL journey, these were the resources that I found useful when getting started. Jonathan, yesterday in his presentation, said that he has a YouTube live stream of 2 hours when you see someone coding stuff. Everybody learns differently. I'm a YouTube person as well, but at the same time, the documentation was pretty helpful, and we have some CTFs in the past that someone can go and use. Yesterday, I've seen the solution of the 2018 SaC challenge. I don't know if in the future someone comes and says, oh, that's the 2017 CodeQL CTF. You never know. So I want to give you these resources as well. Finally, as mentioned by other talks, we have a Slack channel. Here's the URL to our Slack channel. You can just go in that URL and then log in to that. The Slack channel has a lot of people like you from all over the world that are using CodeQL every day to help their companies make money as bug hunters. And in general, you have a nice network to start with. Then we have Github Universe, which is the final thing I want to mention, happening in 1.5 months from now. It's you can attend virtually if you are not going to be in San Francisco Bay Area. There's a security track with loads of presentations. This presentation today was intermediate to advanced. You can have more beginner level there, like workshops, but at the same time, you can have super advanced presentations about the future of CodeQL. And because many people ask me about Copilot and if there's like security in Copilot, I want to answer this question just in case many of you are thinking it. Because I had Copilot enabled in my demo, disabled in my demo, it's here on the bottom right. We believe, and we've seen statistics, that Copilot can make programmers twice as fast. And there are new companies getting into the space, so maybe we do something well. Like Amazon is coming into space with a solution there. It's an AI assistant. It doesn't mean that if you have Copilot on, you should have your code scanning disabled. The best practice is to have your static analysis tools or whatever you are using to secure your code on all the time. The suggestions you get at this time might be vulnerable. And they are affected by your style in the code, by the comments you have, and so many other variables. When I code, I was never given a bad suggestion. But this is because maybe I know a few things about software security. However, we now are working on something called vulnerability filters to avoid Copilot to give back vulnerable code. And in the same way that we are using AI to help our AI assistant in code, we are using AI behind the scenes for CodeQL for the past 11 months. And we've seen a tremendous change in the amount of false positives that we were given in the past by using machine learning. And that's pretty much it. Thanks so much for your attention today. And I'm happy to hear your questions.
All right, so yesterday when we asked, it was like 5 people that had heard of CodeQL before, and I think you were one of them. So I'm actually really curious, how many in here are going to go home and actually look at CodeQL now for your projects?
Ooh.
That is amazing. Okay, that makes me very happy, because I think this is a silver bullet for a lot of things. I discovered it more than like 6 months ago and go like, wow, why didn't I see this before? This is so goddamn useful. It's like crazy. How many people do you think there are that are contributing to this database of samples and then?
Well, if I think about the enterprises around the world, I know that the number can be huge. The bug hunters that are actively contributing are around 500 people. My team is consisted of 20 people, but at the same time, we have the overall software engineering team of CodeQL contributing as well. So the number goes to around 50. But then if I start counting the enterprises that are using it, the number is endless. So I can't give you the figure of the enterprise security people contributing.
That's awesome. Do you have any questions from the Slido thing?
Yeah, we do have the questions from the audience. Is this a GitHub only? What if I run GitLab, or if I want to run this against my private repos? Can you do that? Can you self-host? Can you do the scanning on your own?
Yes, so you can self-host in the same way you have GitHub runners for actions. Same thing for CodeQL. Of course, self-hosting comes with its own challenges and security problems. Now, in terms of integration, you have to be on GitHub as of now. I think that we provide it to others to integrate, but if others don't build that, it's outside of our control to create that integration right now.
Okay, and another relevant question is what if you have projects which are not open sourced on GitHub?
Oh yeah, I failed to answer that. If you have projects that are not open source, you should buy a license to use the product. It's free for public projects like the one I've experimented with here in the demo.
Okay, and another question, which is, most of the examples that we see with CodeQL is fairly easy, like buffer overflows, SQL injections, they're fairly easy to spot. but more complex dynamic problems such as race conditions, etc. Is that something where you're working towards? And is there CodeQL for more complex, like double lock problems?
So there's the functionality in the code base, in the language, to describe many things, as long as you can visit the documentation and understand how you can pick up those conditions by using maybe some methods that are not going to be shown to you in a YouTube training or something like that. But the answer is yes, you can describe pretty much everything that can be described in code. Everything you can think about, it can be described.
Okay, what about other languages? What languages is supported today, and is there a roadmap for Rust and other languages?
Yeah, Rust is already there. What's in the roadmap is Kotlin and Ruby, and right now we have integration with Python, Java, JavaScript, C, C++, Go. That's it, yeah.
Okay, I think that's it for the pre-questions that we had from the audience. Any more questions from the audience? We have one over there.
Is the mic work? Mic run? As you said yesterday.
Yeah, hopefully, yeah. So on this topic with supporting more languages, I was considering, why do it this way? Why don't integrate it into the compiler? The LLVM, for example, has the intermediate representation. That should be excellent to be targeted for this, shouldn't it?
I love the question. That's a good question. Unfortunately, I don't have an answer. So if you contact me in Twitter, I can speak with the team implementing the functionalities and thinking about the future, the strategy, the roadmap, and we can have like an answer there, because it's something that sometimes many people are thinking about, interpreter languages and all these kind of things. Why don't you do this? So I don't have the exact answer, and I haven't had like a comprehensive response in the past to say, oh, this is like expensive to do, or it needs more runtime, or it doesn't help the experience. So more than happy to give you like an answer from the person deciding these kind of things, so you get the expert answer.
All right, thank you.
Also, are you the person that's responsible for rate limiting Mr. Lightshoe?
Jonathan?
Yeah.
I'm not this person, but I think Mr. Jonathan is somewhere in this part of the room. Yes, hi. He's there. He can tell you that I've put some effort in helping him to not get rate limited, but at the same time, we as a company made a more universal decision that in the same way that we don't want to whitelist is a bad word, allow list somebody.
I'm thinking that the rate limiting is actually good for his mental health. Maybe he should have something that kind of slows him down a little bit.
Yeah, so the decision was around the lines of let's be fair to everybody, because maybe actually many people got inspired from Jonathan lately, and you never know how this rate limit could play in the long term when it gets into scale.
No, I get that.
Okay, I have one more relevant question that just came in. There is other alternatives like semgrep. How does this compare to like semgrep in general and the more, how would you compare it to semgrep?
Absolutely. I believe that what we do well is the taint tracking functionality, so you can follow your inputs along the way like I've done in the demo. And the other thing we do well is the community thing. So, of course, semgrep or whatever tool has their own community. I believe that our benefit, or let's say pro, is that this community is built from the past 12 years, and you have enterprises contributing, hunters contributing, and people who have the knowledge, codifying that knowledge into the tool. So this community is something that you can build on top.
Okay, thank you very much. Big round of applause.